Good morning, everybody. Once more, it's a good day, and we continue with our daily activities in YouTube. And today, I'm going to start the day by looking at a video in an area of mathematics where I met a student on Sunday, and they wanted me to expound on evaluation of numerical expressions using mathematical tables. Notice, even when I was teaching, we assume, and the tendency is to rush. So I will first of all, I write, then I give some 3 KCSE questions, and then after that, I might decide to have a lesson plan for the teacher so that this can be effective. So first of all, let me assist this student. The topic evaluation of numerical expressions using mathematical tables involves performing calculations and evaluating mathematical expressions by referencing pre-calculated values in standard mathematical tables. These tables typically include logarithms, trigonometric values, squares, square roots, reciprocals, and other functions. In the comments, you can tell me if you want me to expound on any of these tables. But in my lesson plan for the teacher, I think I will be able to give an example of how you, for example, look for square roots and sometimes look for the logarithms or trigonometric values. The overview of the topic. First of all, we are going to look at the purpose of mathematical tables, and mathematical tables provide quick access to approximations of complex mathematical values. They are especially useful when calculators or computers are not around or available. In fact, in the examination, they emphasize you use the mathematical tables and the calculators must not be near there. Number 2 is key components in the mathematical tables, and as already alluded up there, we have the logarithms, tables for common logarithms in base 10 and natural logarithms in base E. And logarithms used to reverse logarithmic values to original numbers. Then we have trigonometric ratios, that is the table for sines, cosine, tangent, and their inverses. And then we have squares and square roots, tables listing numbers alongside their squares or square roots. Application: simplifying calculations by breaking expressions into manageable parts, solving problems in logarithmic and exponential equations, evaluating trigonometric expressions in geometry and physics. So what candidates need to know, or what should the candidates know? 1 is reading and interpreting the tables. You are supposed to locate and interpret values accurately from the tables, understand interpolation methods for non-resistant values. 2. Steps in using mathematical tables. Break down numerical expressions into parts that can be looked up in the table. Apply addition, subtraction, multiplication, division based on logarithmic rules or other principles. Logarithmic and anti-logarithmic operation. You are supposed to be familiar with the properties of logarithms. That is, the logarithm of a times b is the same as the logarithm of a plus the logarithm of b. And the logarithm of a divided by b is equal to the logarithm of a minus the logarithm of b. And the logarithm of a raised to n is equal to n times the logarithm of a. Using anti-logarithms to revert the results to standard form. 4. Trigonometric evaluations. Correct use of trigonometric tables for angles in degrees and minutes. Applying interpolation techniques for non-standard angles. 5. Accuracy and rounding off. Correct rounding off of results to the required significant figures or decimal places. 6. Practice and common errors. Avoid misreading the tables or interpolating incorrectly. Cross-check computations to ensure consistency and accuracy. Tips for mastery. Understand the fundamentals. Develop a clear understanding of logarithmic and trigonometric principles. Practice thoroughly. Solve a variety of problems to get comfortable with table navigation and interpolation. B. Be precise or be exact. Pay attention to detail when reading values and applying operations. Check answers. Validate results by alternative methods when possible, e.g., calculator or approximate estimation. Notes on evaluation logarithms. These are used for simplifying multiplication, division, and exponentiation. And the key formulas, remember, are the logarithm of a times b is the logarithm of a plus the logarithm of b. And the logarithm of a over b is equal to the logarithm of a minus log of b. And the logarithm of a raised to n is equal to n times the logarithm of a. Anti-logarithms, this is the reverse process of logarithms to find the original value. And then trigonometric ratios, tables list values of sine, cosine, and tangent of angles in degrees and minutes. For non-standard angles, interpolation is required. Interpolation is a method to estimate values between two tabulated entries. I will give you an example later. Use the difference column provided in tables to calculate the adjustment. Squares and square roots. Direct lookup for simple squares and roots. Break large numbers into standard form. So break large numbers into standard form, e.g., a times 10 raised to b. All right? Where a lies between 1 and 10, and it is not 10. Accuracy and rounding off. Follow the instructions for significant figures and decimal places in the problem. For consistent rounding to avoid errors. Common errors to avoid are misreading table values, forgetting to adjust for powers of 10, and incorrect interpolation. Evaluating a logarithmic expression. This is example number 1. Evaluate 73.5 times 0.00452 using logarithm tables. So the solution, the first thing you do is you express the problem in terms of logarithms. And you can see using that first rule, the logarithm of 7.5 times 0.00452 is the same as the logarithm of 73.5 plus the logarithm of 0.00452. Next, look for logarithms in the table. And when you look for the table, you find the logarithm of 73.5 is 1.8664. And the logarithm of 0.00452 is negative 2.3444. Not negative because the number is less than 1. We'll come to the nitty-gritties of this. And the logarithms, so you have 1.8664 plus negative 2.3444 gives you negative 0.4780. Find the antilogarithm, look up antilog, negative 0.4780, and it is 0.333. So the answer is 73.5 times 0.00452 equals 0.333. The logarithm of 0.00452 is equal to negative 2.3444. So I want to elaborate what we mean by this negative, because normally we don't give the whole logarithm as negative. We have the first part, which is known as the characteristic, and the second part known as the mantissa. The characteristic is always can be negative or positive, depending on the power of 10 when the number is expressed in standard form. So, note, negative because the number is less than 1. How do you get this from the tables? To calculate 0.0452 using mathematical tables, follow these steps. Express the number in standard form. So it is 4.52 times 10 to the power negative 3. Here, 10 raised to negative 3 contributes to the characteristic, which is negative 3 over the power of 10. And in logarithmic notation, we normally write it as bar 3. So that one is read as bar 3. Excuse me, guys. The power of the computer was off. It's a problem with the power of the computer. So the computer informed me the power is off. Sorry, guys. So negative 3 is normally written bar 3. Locate log 5.52 in the tables. So open the logarithm table and locate the row for 4.5, the first 2 digits of the number. Find the column for 2, the third digit of the number. The value from the table for row 4.52 is 0.6544. This is the mantissa, the decimal part of the logarithm. So guys, when watching this video, you are supposed to be having the mathematical table on your desk. Remember always I said, mathematics, you don't read, you should do. And so you should have a pen and paper. Now combine the characteristic and the mantissa. Since 0.0452 is less than 1, its logarithm will be negative. Using the characteristic of negative 3 from 10 raised to negative 3 when the number is expressed in standard form, the logarithm of 0.00452 is negative 3 plus 0.6544. And when you do the subtraction, this is why when you are getting negative 2.3444. But normally, we write it as bar 3 plus 0.6544. Write the final logarithmic value, and you find that the final is bar 3 plus 0.6544, or you give it the whole of it negative as negative 2.3444. Note, characteristic or power of 10, when the number is expressed in standard form, can be negative, but mantissa is always positive from the mathematical tables. Characteristic and mantissa. The characteristic is the integer part of the logarithm determined by the magnitude of the number when the number is expressed in standard form. A times 10 raised to n, where a lies between 1 and 10. It can be 1, but it cannot be 10. The mantissa is always positive and is found from the tables. Negative characteristics. When the number is less than 1, the characteristic is negative, but the mantissa remains positive. Adjust the calculation accordingly. Solving a trigonometric expression. Find sine 47 degrees, 22 minutes. Solution, first of all, locate sine 47 degrees in the trigonometric table, and you find that the answer is 0.7314. Locate the difference for 22 minutes, interpolation. So difference per minute is 0.0011 from the table. Total adjustment will be 22 times 0.0011, which is 0.024222. Add the adjustment to the sine of 47 degrees, and you get 0.7314 plus 0.0242, which is equal to 0.7556. And therefore, the sine of 47 degrees, 22 minutes is 0.7556. Finding the square root. Find the square root of 458 using tables. Express the number in standard form. So it will be 4.58 times 10 squared. Remember, you move with the decimal point so that the number lies between 1 and 10. So if you move the decimal point of 458, which is at the end, they will land between 4 and 5. And since it has moved 2 steps, then the power of 10 will be 2. The power of 10 is the number of steps the decimal point moves. Look up the square root of 4.58 in the table, and you find that the square root of 4.58 is equal to 2.141. So the square root of 4.58 is equal to 2.141. And just for 10 squared, you get the square root of 10 squared is 10, and therefore the square root of 458 is equal to 2.141 times 10, which is 21.41. And therefore the answer is square root of 458 is 21.41. Now, guys, here we come. In 2006, question 1 of paper 2 was evaluate using mathematical tables. No calculators. So in this question, Show all the steps in your calculations, giving your answer at each stage. Use logarithms correct to 4 decimal places to evaluate that 4 marks. We will look at how they did it. But you can pause and try it before you look at my working. In 207, paper 2, question 1, you can see there are always question 1. Use logarithm tables to evaluate. 0.032 times 14.26 over 0.06 raised to 2/3, 3 marks. Use logarithms to correct to 4 decimal places to evaluate the cube root of 83.46 times 0.054 over 1.562, 4 marks. This was 2011, paper 2, question 1. You can see this question is like it always occurs in paper question 1. It is always question 1 in paper 2. So this is the way it was marked. So you can see 206, paper 2, question 1, where you have number, solution, marks, and comments. So you have a number, express the number in standard form. All right. Okay. So, for example, here you are getting this direct. Here you find the logarithm of 4.6 times 10 to negative 1 is by 1.6628. You multiply by 2 because it is squared. You get the logarithm to be by 1.3256. Remember here, I'm not giving the whole number negative. It's only the characteristic which is negative. When you add them, you are going to get 0.98905. All right. Here, if 0.46 is squared first, follow through question around all the marks. All right. So they can square first and then find the logarithm. M1, method 1, all 3 logs you give 1 mark, all 3 logs correct. M2, operations of multiplication, square, addition, and subtraction, you are giving 1 mark. And the other method mark is attempted to divide. And here you are. And you divide by when you find the cube root of the expression. So you divide the logarithm by 3, and what you get is by 1.5408, and when you unlog, you get 3.474 times 10 raised to negative 1, and the answer is 0.3474. So the total mark you can see is what? 4. And this is the way the mark is distributed, the marking. For 207, similar things. All logs you are giving a mark method. Operations and attempt to multiply by 2 and divide by 3, another mark. And then the answer, 17.95, you also get a mark. I don't think there is anything you'd like to be explained there, because things are straightforward. All right. Finally, 2011, paper 2, question 1. All logs you get a mark correct. All logs, method mark operations, method mark attempt to divide by 3, and you get the answer. Antrog, and the answer is 0.57001. So that is the way you arrange your work. Have a paper and pen for being good in mathematics. So today we have explored how to evaluate numerical expressions using mathematical tables, a skill that simplifies calculations and enhances accuracy in solving complex problems. As you practice, remember the importance of neatness, systematic work, and attention to detail when reading and interpreting values from the tables. These skills are not only vital for your exams, but also applicable in real-life problem-solving scenarios. Keep practicing to build confidence and precision, and don't hesitate to revisit this lesson if you encounter challenges. Well done for your active participation, and see you again in the next lesson. So there, acknowledgement to the contributions. And guys, there comes to the end of my video. I hope it has helped you, and you are going to do more practice by following the guidelines I've given you. Goodbye. Don't forget to subscribe to this channel for more videos. Goodbye.